We are talking about Minkowski distance in machine learning. So machine learning is all about clustering of data. Data are placed in clusters. If they are not placed in well clusters, then we use various algorithms to distribute it in clusters. So data has to be in clusters. Now if I have a test data, means trained data has to be in clusters. If I have a test data, then test data, it should belong to a cluster. How it would go and map to a particular cluster, one of them. That is the kind of the idea of machine learning. There are many ways where we can kind of map the test data to a particular cluster, kind of neural network or Bayes theorem, NLP, or decision tree. There are so many. One of the basic way to place a trained test data to a particular cluster is finding the nearest cluster from the test data. If I have a test data, then all clusters in the test data, they have a distance. So if we are talking about strings, then Levenstein distance that comes into the picture, where it talks about the distance between two strings. So if I have a string A and B, what would be its distance? So if I calculate the distance of a test string with all the trained string, the nearest would be where it would go. So that is Levenstein distance. There is another distance called Minkowski distance. Minkowski distance is about numeric value rather than string. It's about numeric value. So if I have a trained data of single dimension, 2-dimensional, 3-dimensional, 4-dimensional, or n-dimensional. So 2-dimensional, single dimensional means it is on a particular axis, x-axis or y-axis. 2-dimensional means it is on xy plane. 3-dimensional means it is on xyz plane, like if it grows in the dimension. So Minkowski distance is a kind of a distance between 2 points that we can calculate, and these 2 points, the distance what we get, upon this distance we can now estimate that this test data belongs to which cluster. So we have set of clusters and we keep on calculating the distances, nearest cluster where this test data belongs. So that is Minkowski distance. Under Minkowski distance, two distance comes into the picture. One is Manhattan distance, one is Euclidean distance. So Euclidean distance is, I think, it's well known. If I have a 2-dimensional data, that is x and y, and means one is x, that is x1 and x2, and other is y, that is y1 and y2, then distance would be a subtraction of each dimension, and then we have to place a root over their squares. So that is Euclidean distance. There is a Manhattan distance, where it's a kind of, it is called like a taxi distance, where we go in one direction, we end up, and then we move in another direction in 90 degrees. So if I have to find a distance between kind of 2, 2 and 4, 4, then we will move along x-axis 2 to 4, then we will move along y-axis 2 to 4. So this is Manhattan distance. Euclidean distance is a kind of diagonal. So if 2 points are there, and if I make 2 points as 2 end of a rectangle, then it would be the diagonal distance. So these two are the distances that comes into the picture, Euclidean and Manhattan. If we combine both, kind of a union of these two distances, then it comes to Minkowski distance. So Minkowski distance is to find a kind of a cluster where a test data belongs to, and this decision of finding the process of finding the exact cluster is the distance between the test data and the cluster points. So through Minkowski distance, if data is n-dimensional, like we talked about right now, two-dimensional x and y, it can be x, y, z, and so many. So that we'll see that how we can calculate the distance between 2 points in Minkowski distance. And then followed by we'll place an example where like if I have a RGB image, then RGB means it comes to 3 dimension. So how two images, how far they are from one image to another image, and how we can kind of calculate the distance, and how we can kind of we can map one image to other through Minkowski distance. So that as an example that we'll see. Further to the discussion on Minkowski distance. So we'll see the slides and example. This is Linux. So we'll go find website. So Minkowski distance, like it is to find the distance between two coordinates. Coordinate can be multi-dimensional. Different algorithms are used at each dimension. Okay, so it's a kind of combination of two algorithms, two distances, used mainly for numeric value. It's not like a Levenstein distance where it is used for find the distance between two strings. Minkowski distance, like if there are two buildings, then there are distance between it. If there are two strings, there are distance between it through Levenstein distance. If there are two coordinates, here it is of dimension 4, then what would be distance between these two? If there are two strings, distance can be found out by Levenstein distance. If there are two entities, two kind of coordinates with here it is 4-dimensional, what would be distance between two? So here Minkowski distance comes into the picture. Okay, so first we'll talk about Manhattan distance. If there is a point X, there is a point Y, then distance has to be in X direction. We have to move till we reach here, and then in Y direction, or we can go like a staircase like this. So this distance, red one and plus green one, this distance. If we add these two distances, it becomes Manhattan distance. So if I have n coordinate points, then first one minus first one of the second coordinate, first point 1 first coordinate, 2 first coordinate, if I subtract and then keep adding and go up till the last coordinate in the point, that becomes Manhattan distance. So in graphics also, like this is 2-dimensional, x to y, and if the x and y are 3-dimensional, if it is alpha 1, beta 1 and gamma 1, and then another point has coordinate alpha 2, beta 2 and gamma 2. First, it moves along the one axis, then another axis, and then on another axis. So, it could be like along x-axis, y-axis, and then z-axis. So, distance between x and y would be alpha 2 minus alpha 1 plus beta 2 minus beta 1 plus gamma 2 minus gamma 1. So, that is Manhattan distance. Let's talk about Euclidean distance. This is another kind of distance where if I have 2 points x and y, then the distance between x and y is alpha 2 minus alpha 1, beta 2 minus beta 1, gamma 2 minus gamma 1. Then we have to square it and then a square root of all the addition. So that comes to Euclidean distance. In the 3D graphics, it would be like that. If there are 2 points x and y, then this is the distance, right? So that is supposed to be the shortest distance between these 2 points. So we talked about Manhattan distance. That is a kind of axis distance. We move along axes and find the distance. Whereas in Euclidean distance, we try to get direct distance. What is Minkowski? So, if we see the formula, then it is xi minus yi, that is Manhattan distance. Xi minus yi square, then square root. Here, if I say instead of 2, it is 1, and instead of 1 by 2, it is 1 by 1. So, Euclidean distance becomes Manhattan distance. So, we would generalize it to a p, x minus y power p, and then to the power 1 by p. This becomes Minkowski distance. So, this is Minkowski distance. If I have 2 points x and y of n dimension, then for each dimension we subtract raised to the power p, then we add it, and then we calculate 1 to the power p. That comes to Minkowski. It can be kind of a superset of Euclidean distance and Manhattan distance. Okay. So in RGB, in image world where we have 3 coordinates mainly, if I exclude alpha, then for every pixel has RG, R1, RG and B, red, green, blue. So if I need to find distance between 2 pixels in an image, that distance would be D. So as per the Minkowski distance, so if I follow Euclidean distance, then it would become R1, R2 minus R1 square, and G2 minus G1 square, B2 minus B1 square, and the square root. So that would be the Minkowski distance if I consider the power 2 between the 2 pixels. Okay, so let's proceed in the Minkowski distance. Okay, so I have a point called which has coordinate alpha, beta and gamma 1, and I have a point which has distance alpha 2, beta 2 and gamma 2. The Euclidean distance or Minkowski distance between these two is capital D. If I am at distance x and it has a coordinate ABC, it has a coordinate value ABC, what would be ABC? Okay, so it's not that difficult. It would be alpha 2 minus alpha 1 and then divided by the distance into x plus alpha 1, similar to beta 1 and similar to beta and gamma. Okay, so what we want to achieve here is that given a distance d, and then for variable x, where x is here, and it will vary along the line. So it will vary along the line. And what would be the coordinate ABC? Okay, so there is a mathematics and we come to same simple conclusion, like x would be a minus alpha 1 and beta b minus beta 1 and c minus gamma 1 to the whole square, and slowly we will come to a calculation, and if we differentiate through d alpha. Okay, so on the right side we'll go with simple mathematics of differentiation, and slowly we'll come to the same result what we were talking about. A minus alpha 1 equal to x into alpha 2 by alpha 1 divided by d, and then it comes to a equal to x into alpha 2 minus alpha 1 divided by the capital D, where is that is the Euclidean distance between these two, and then the alpha 1. So if I know alpha, beta and gamma, that is the begin point. If I know the distance d, and if I know the end point alpha 2, beta 2 and gamma 2, for any distance x, the coordinate of ABC would be this. Okay, so Minkowski distance will prove it. Like if I have an image, two images of equal width and length, then every pixel between two pixels of the images, like I have two images, one image is this and another image is this. Every pixel has RGB, that comes to three triple dimension. Two coordinates are there, and every pixel, between every two pixels there is a distance. So if I okay, so between every two pixels there is a distance. So idea is that if I can able to calculate the Minkowski distance, then through this formula can we transition and one image to another image, so that we feel that Minkowski distance works. Like example image we have taken, like I have a kind of face of a cat, and then this is source image and this is the target image. Now every pixel between this tiger and the cat, we know the distance, we know the maximum distance. So what we would do is, so we know the d, that would be kind of maximum distance between all the pixels, and then for every pixel we now, if we know maximum distance, then pixel by pixel we can proceed x, like x can be 1, 2, 3, 4, or I can say 1, then next time 2, next time 3, next time 4. Based upon the varying x, we would calculate ABC, new ABC, And so if I have new ABC, then I will have a new image. So for every pixel, we will calculate a distance from the pixel. For that distance, we will calculate a new RGB, and that RGB we will draw. So this is the first image, this is the second image, this is the third image. So slowly image is kind of proceeding from the source to target. Like if I have alpha, beta and gamma, and then I have to reach alpha to beta to gamma, then X we can start from 1, proceed to 1, 2, 3, 4, 5, 6 till it reaches alpha, beta, gamma. That is the distance D. And keep on calculating ABC, and then for each pixel we draw the ABC. And slowly we will see that since the pixel value is approaching towards alpha 2, beta 2, gamma 2, that is alpha 2, beta 2, gamma 2 here. From alpha 1, beta 1, gamma 1 here. Then slowly we will move towards the other image. That is the idea. So we can see that cat image is slowly coming to a transition, and then it becomes the target image. Okay, so we'll proceed for the coding part. So we'll see that how we can calculate the Minkowski distance, and then how we can calculate the Minkowski distance, and then how we can transition an image from source to target. So we'll use a Python package Kiwi, because we now need a kind of texturing, splitting the texture from image data. So we need OpenGL for this concept. So OpenGL through Python, it works well in Kiwi package. So we'll use Kiwi and we'll see.